Hello students, I am continuing with exercise 1.4 chapter number system. Question number 1. Visualize 3.765 on the number line using successive magnification. Visualize 3.765 on number line by successive magnification. What do you mean by successive magnification? Successive means one after the other. Magnification. All of you listen here. What is meant by successive magnification method? And how can we express or how can we show 3.765 on number line? Normally using a scale, whenever you draw the number line, we will take 1 centimeter is equal to 1 unit. So you will write 1, 2, 3, 4. Then in between if you make 10 small line, each small line will represent 0.1, 0.2, 0.3 like that. So 3.765 is not possible to show by that method. So we are going to use another method which is called successive magnification method. In the first step, we will show this given decimal number lies between which two integers. We know that 3.765 lies between 3 and 4. So we will draw a number line in which we take 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have divided this number line into 10 equal parts. You have to do it by proper measurement. Mark these points at 1 centimeter. So this is a number line showing 1, 2, 3 up to 10. We know that 3.765 lies between 3 and 4. So you just show 3.765 like this. Showing that 3.765 lies between 3 and 4. Now we are magnifying this portion, only this one unit between 3 and 4 into 10 times. This portion is going to be magnified 10 times. So how? I am going to draw another number line where I am taking this 3 here and I am taking this 4 here. This portion, this 1 unit portion is magnified into 10 times. So you may show like this. This is the 3 and this 4 is actually that. Now divide this portion 3 to 4 into 10 equal parts. Now at 1 centimeter, you may mark 3, 4, 5, 6, 7, 8, 9. So the space between 3 and 4 is divided into 10 equal parts. So what will be the value of each of this point? 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8 and 3.9. I hope you understood this step. This 1 unit portion is magnified 10 times. So this is 3 and this is this 4. Show that 3 and 4 by longer lines. Now divide it into 10 equal parts by using a scale. So each of them will be like this. Now see, where does this decimal lies? 3.765. 3.765 lies between 3.7 and 3.8. So you show 3.765 like this. So 3.765 lies between 3.7 and 3.8. Now we are magnifying this 3.7 to 3.8, that 1 unit space into 10 times bigger. So in the next number line, I will take the first point as 3.7 and the last point as 3.8. Now I am dividing this portion into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now what will be the value of this first one? If it is 3.7 and that is 3.8, then this will be 3.71. This will be 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.78, 3.79. Our number is 3.765. 3.765 lies between 3.76 and 3.77. So we will show it like this. 3.765 lies between 3.76 and 3.77. Yes, this is the magnified form of this. 3.7 and this is 3.8. Now we are going to magnify this portion 3.76 to 3.77 again into 10 times. So the next number line, the first point will be 3.76 and the last will be 3.77. So 76. .76 is magnified. 3.77 is also magnified. Now again divide it into 10 equal parts. 3, 4, 5, 6, 7, 8, 9. Now what will be each of them? This will be, since it is 3.76 and 77, each of them will be, this will be 3.761, this is 3.762, this is 3.763, 3.764, 3.765, 3.766, 3.767 and 3.768, 3.769. Now what is our number? 3.765. We got 3.765 exactly on the number line. So this is the position of 3.765 on this number line. This method is known as successive magnification method. I repeat, in the first line we will show the given decimal number between two integers 3 and 4. Now that 3 to 4, 1 unit is magnified 10 times, again 10 times, again 10 times. Each step you have to identify where is our number, where does our number lies. Then that 1 unit is magnified into 10 times, 10 times, 10 times, unless you get exactly the same number which is ours. This method is known as successive magnification method. Now question number 2. Visualize 4.26 bar on the number line up to 4 places of decimal. Visualize 4.26 bar up to 4 places of decimal on the number line by successive magnification method. 4.26 bar up to 4 places of decimal means 4.2626. Just like the previous question. Now this time 1 digit is more. In the previous one, after the decimal there were 3 digit, now 4 digit. That means the same method is to be followed. This time you have to draw the number line one more time. So what will be the first step? 4.2626 lies between 4 and 5. So draw a number line 1 to 10 and take the portion between 4 and 5 and show that 4.2626 lies between 4 and 5. Then magnify 4 and 5. Divide it into 10 places. 4.1 to 4.9. It will lie between 4.2 and 4.3. Again magnify and so on, so on, so on. Finally you will get exactly 4.2626 exactly on the number line. So please do it as homework. Now let us continue with the next exercise, that is exercise 1.5. Before we move to the questions of exercise 1.5, I would like to teach you some important points. Now the next topic is, if two irrational numbers, or if a rational number and an irrational number are added, subtracted, multiplied and divided, what will be the nature of the answer? That is our next point. Please listen carefully. If a rational number, the sum or difference of a rational number and an irrational number is always irrational. Means, if you add a rational number with an irrational number, the answer will be irrational. If you subtract an irrational number from a rational number, or if you subtract a rational from irrational in any order, the answer will be irrational. So the sum or difference of a rational number with irrational number is irrational. Second point, the product or quotient of a non-zero rational number with an irrational number is also irrational. I repeat, the sum and the difference of a rational number with an irrational number is irrational. So 2 is a rational number, root 5 is an irrational number. Rational plus irrational, answer is irrational. Second point, the difference of a rational number and an irrational number is also irrational. Third point, the product of a non-zero rational number. We know that 0 is also a rational number. With 0 it does not apply, it's not applicable for 0. Any non-zero rational number into any irrational number. 2 into root 5. 2 into root 5. That is 2 root 5 is also irrational. Now, the quotient of a non-zero rational number with an irrational number is also irrational. Sum of rational and irrational, irrational. Difference of rational and irrational, irrational. Product of a non-zero rational with another irrational is irrational. Quotient of a non-zero rational number with an irrational number is also irrational. So next exercise 1.5 is based on these properties. I am doing question number 1, and question number 1 is classify the following numbers as rational or irrational. Question number 1, 2 minus root 5. Same example was taken by me just now. So 2 minus root 5 is irrational. I have explained just now. Because rational minus irrational is irrational. Number 2, 3 plus root 23 in bracket minus root 23. Opening the bracket, it becomes 3 plus root 23 minus root 23 plus root 23 minus root 23 will get cancelled. Answer is 3, and we know that 3 is rational. So the answer is rational. Question number 3. 2 root 7 upon 7 root 7. We know that root 7 and root 7 can be cancelled, is equal to 2 upon 7, and all of you know 2 upon 7 is rational. Next question, 1 upon root 2. Question number 4, 1 upon root 2. Just now we have seen rational divided by irrational is irrational. And question number 5, that is the last question, and it is 2 pi. I hope all of you remember what is pi. Pi is C upon D. Circumference of a circle upon its diameter. This ratio is called pi. And you might have studied the value of pi in class 8. The value of pi is taken in two ways. Or sometimes we take it as 22 upon 7. Sometimes you take it as 3.14. But remember, both the values are wrong. The exact value of pi is neither 22 upon 7 nor 3.14. Pi is a non-terminating, non-recurring decimal. The value of pi is actually in decimal. It is 3.1456 dash 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 up to infinity. The actual value of pi is a non-terminating, non-recurring decimal. So we know that all the non-terminating, non-recurring decimals are irrational. Only for the sake of calculation, only for the easiness of calculation, we take it as 22 upon 7 or 3.14. But remember, pi is an irrational number. 22 upon 7 and 3.14 are not the exact value of pi. So remember, pi is irrational. Its actual value is 3.14 dash dash dash, which is a non-terminating, non-recurring decimal. since pi is irrational and 2 is rational, rational into irrational, the answer is irrational. So 2 pi is also irrational. So remember the very important point, pi is irrational. So if pi is multiplied or divided by any other rational number, the answer will be always irrational. This is question number 1 of exercise 1.5. Now let's see question number 2. Now question number 2. Simplify each of the following expressions. First part, 3 plus root 3 into 2 plus root 2. Simplify. This is just like the multiplication of any other number. 3 plus root 3 into 2 plus root 2. First 3 into 2, 6. 3 into root 2, 3 root 2. Root 3 into 2, 2 root 3. Root 3 into root 2, root 6. So remember some important points while doing this calculation. 3 into 2, 6. 3 into root 2 is 3 root 2. These root 2, root 3 are also known as surds, S-U-R-D-S. These surds are to be treated just like x and y in your algebra. Means root 3 and 2 cannot be multiplied together. It is not root 6. Root 3 will remain as root 3. Root 3 can be multiplied with only another root number, not with a rational number. So root 3 into 2 is 2 root 3. 3 into root 2 is 3 root 2. Now see the next step. We have a 3 root 2 term, 2 root 3 term. These two terms cannot be added because here we have root 2 and here we have root 3. It is just like x and y. X term and y term cannot be added. So a root 2 term can be added or subtracted only with another root 2 term. Similarly, a root 3 term can be added or subtracted only with another root 3 term. Otherwise, it will remain separated. So no more simplification is possible now. So this is the answer. Question number 2. 3 plus root 3 into 3 minus root 3. 3 plus root 3 into 3 minus root 3. We know that it is in the form of a plus b into a minus b is equal to a square minus b square. So 3 square minus root 3 square. 3 square is 9. Root 3 square is 3. Root 3 into root 3 is 3. So 9 minus 3 is equal to 6 is the answer. Question number 3. Root 5 plus root 2 the whole square. Root 5 plus root 2 the whole square. This is in the form of a plus b the whole square. What is a plus b the whole square? A square plus 2ab plus b square. So expand it using the formula a plus b the whole square. Root 5 the whole square, a square, plus 2ab, 2 into root 5 into root 2, plus b square. B square means root 2 the whole square. It is root 5 the whole square is 5, 2 into root 5 into root 2. Yes, this time we can multiply root 5 and root 2. So two surds of different values can be multiplied. Under root 5 into under root 2 is under root 5 into 2, that is under root 10. So remember, under root A into under root B is equal to under root AB. Remember it. But under root A plus under root B, no more simplification. A and B are different surds, so they cannot be added. Similarly, under root A minus under root B is also not possible. It is under root A minus under root B only. But under root A into under root B is equal to under root A into B. Similarly, division is also possible. Under root A upon under root B is equal to under root A upon B. A and B can be divided and put under root side. So multiplication and division is possible between two different sets, but addition and subtraction are not possible between two different sets. So 2 root 10 plus root 2 square is 2. So 5 plus 2, 7 plus 2 root 10 is the answer. Now question number 4, this is the last question. Root 5 minus root 2, root 5 plus root 2. Root 5 minus root 2 into root 5 plus root 2. It is again in the form of a minus b into a plus b, which is equal to a square minus b square. Root 5 square is 5, root 2 square is 2, 5 minus 2 equal to 3. So I am winding up today. So we have done exercise 1.4, successive magnification method for representing a decimal number on number line. Then we have seen some properties of operations of rational number with irrational number. I will come with more properties of irrational numbers in my next class. Till then, practice, take care, goodbye.